Now to start off, we're going to be revisiting the meme fighter code base, but before we get started on the main topic, got a little bit of mea culpa here because in the last video, made a big mistake, forgot to put in the virtual destructor, and that, my friends, is not cool. So I'm going to set that straight, and we'll commit that quickly right here. We'll save that. I'm sure that'll work. Well, first thing I want to do here is just take a look at some places where pointers and specifically dynamically allocated memory can kind of fuck you over. So, place number one, you've got to delete that stuff when you're done with it. What happens if you just, forget to delete this, forget to write this loop? It's very, very likely that you're going to do that. And you've just leaked a bunch of memory. So congratulations on your brand new memory leak. Where else can things fuck up? Well, let's say I create a meme frog A, I give him some fists, then I create a meme frog B as a copy of A. How is this going to mess us up? Because it is going to mess us up. You already know this. B is equal to A, all right? Now we're going to destroy A and B, and we get a big fat exception. Why the hell do we get that exception? Well, it's pretty goddamn simple. This A is owning this resource, new fists by pointer. The default copy constructor is going to do a shallow copy. So now B and A both have pointers to fists. When you destroy, it's going to destroy B. B is going to destroy the fists. Then it is going to try to destroy A. A is going to try to destroy the fists again, which you can't do, and you get a big fat exception. So obviously, this default copy constructor ain't doing it for us. It's going to mess us over if we try to use it. Now, if we take a look at the function pilfer weapon, it's going to remove a weapon from a fighter. Now, what if we just want, let's say we just want to take the weapon away from the fighter. We don't want to give it to anyone else. Someone might write the code, giver.pilfer weapon, and that's it. It'll remove the weapon from the fighter. Job's done. Except, of course, you've just leaked memory here. It returns a pointer to that thing, the resource, and you've just dropped that on the floor, and now that memory is leaked. So here are some places where we can get screwed over with pointers to heap memory. How can smart pointers, specifically unique pointer, solve all these problems for us? Because it can solve all these problems, and that is freaking awesome. All right, check this setup here. We got a class with announcers. We're going to create an instance on the heap. We're going to delete that. Run this, and you get the pube ctor, you get the pube dtor. That's fine. You forget this delete here, you leak some memory. Now, how does this look with unique pointer? Well, you're going to include memory. Then down here, let's create a unique pointer. So std unique pointer, and you template it on the type pube. Not pube pointer, just pube. It's a unique pointer to pube, so you template it on pube. And then we can create that p, and we can pass it the pointer of a pube in the constructor. And that's going to construct this unique pointer. This unique pointer now owns this pube object on the heap. We run this, and again, we see pube ctor, pube dtor. Beautiful. What's happening here? We didn't call delete. We didn't have to call delete. Well, the thing about unique pointer and about smart pointers in general is they are RAII enabled, and what they do is in their destructors, they're going to free the memory of the objects that they own. So you don't have to do that, and more beautifully, you don't have to remember to do that. So if you forget to, it doesn't matter because you don't have to remember. Unique pointer does it for you when it goes out of scope. Now in modern C++ code, we don't want to see this new anywhere. We don't like it. We hate it. So what we have is we have a function called std make unique. We'll go pube. That will create a unique pointer to something, and here you would put the parameters for the constructor. So this constructor takes no parameters, so we don't have to put anything in here. But you pass the parameters to the constructor in here, and it will create a make unique. You don't have to call new directly. It does the same thing as calling the constructor and passing it a pointer, but this is the preferred way of doing it. It's a little long to type that out twice, so what we generally do is we go auto p is equal to std make unique pube. This is the preferred form of creating your unique pointers. Now, unique pointer has a bunch of overloads that make it look and feel like a normal pointer in most circumstances. So here I've added a copy constructor. I've added a little member function to the pube. I've added some functions here, fgh, that take a pube in various modes by value, by reference, by pointer. Now, if I want to call those functions, all I got to do is, well, if I want to call it by value, all I got to do is go f and star p, and there you go, just like dereferencing a normal pointer. Same if I want to call it by reference, just dereference it and pass it in. Now, if I want to call by pointer, it's a little different. You've got to call p.get. So if you want to get the underlying pointer, you call p.get. Unique pointer does not implicitly convert to just a naked pointer, and that is to prevent you from accidentally passing it to a function that might want to accept ownership of a pointer by naked pointer. So here you've got to call .get just to make sure that you're thinking about what you're doing. And if you run this, we got the constructor, then we're passing in by value, so it does a copy, calls member function, and then it destroys the copy, and then here we're just calling member function, and then we destroy the original pube. So everything is fine there. Not too different from a normal pointer except for the .get part. You can also dereference and access members directly, just like a normal pointer with the pointer to operator. Now with operator new, you also have new, where you can create a new array or a block of objects. And you can do that with make unique as well. You just got to go pube, and you need to do the square brackets afterwards. And now you are creating an array of pubes, a dynamic array. And you have to put the number here in the brackets. That's the parameter. So now I've got 5 pubes that are being owned by this unique pointer. And I can do, for example, pube at 2.mint. And all those pubes are going to be destroyed afterwards. So if I run this, you're going to see 5 destructors called. There you go. All right, let's make things a little more interesting here. I've created a class Pube Grabber, and it can own a pube. And we got some functions to give it a pube, to take its pube away, and of course the destructor to delete the pube if it's holding one. So here we're going to create a Pube Grabber. We're going to create a pointer to a pube on the heap, and then we're going to pass our pube to the Pube Grabber. If we run this, we should see the pube is destroyed. It's going to be destroyed from the destructor of the Pube Grabber when the Pube Grabber goes out of scope. But yeah, it gets destroyed. That's fine. Now, let's say, we're writing some code. Maybe it's late at night. We see, we're creating a new pube here, so we got to destroy that pube. So we go delete p. All the while not realizing that we've actually already given that pube to the Pube Grabber. So we're going to delete twice, and we're going to get an exception. Right? So this isn't a good situation. If we were using smart pointers, this would never happen. All right, so let's rework this now to use smart pointers. First thing, when you create your pointer, you're going to create it with make unique. Now, when you do this, you can't pass a unique pointer to a function that is trying to accept a normal pointer. So what we're going to do is we're going to rework Pube Grabber to use smart pointers, and this is going to give us a lot of benefits. So first off, this should be a smart pointer. And we want to pass that guy in by value. When you're transferring an object to something else via a function, you should use value semantics when doing it with unique pointers. So this is a unique pointer. We should also own the pube inside of here using a unique pointer. So let me just copy this, paste it in here. So now our ppube, we don't have to make that null pointer. We're going to be owning it with a unique pointer. Now, here are some problems. First of all, we've got this unique pointer. We're trying to pass it to this thing. This thing takes a unique pointer. And you might be saying, well, why doesn't this work? It says something cannot be referenced. It is a deleted function. And the thing that can't be referenced, it's a lot of error codes here, but it is the copy constructor. You cannot copy a unique pointer. And this is why I taught you move semantics before teaching you unique pointer. Unique pointer is prevented from copying, and that prevents you from, for example, making a duplicate and then doing something like double deleting. You can't double delete if you use unique pointers properly because you can't copy it. You can't copy ownership. So if you want to transfer it what do you think you got to use? Say it with me, std move. You do std move because although unique pointer does not have a copy constructor, it does have a move constructor, and that will transfer ownership. It will pilfer the pointer from unique pointer. So this one is now going to point to null pointer. It's going to be empty, and it's going to be transferred into here. And then we want to transfer it from this into here. So we do ppube is equal to std move p. Now the same idea for when we're going to get the pointer from the Pube Grabber. We're going to return a unique pointer by value, and we're going to return it like this. But here, of course, we can't return this one because it'll create a copy, not allowed to copy a unique pointer. So you do, again, std move. And that both removes it, so now we don't have to set the null pointer or anything. It removes it from here, puts it here. So now you see this control, using move semantics, we control the ownership of the object. It can't be owned by two places at once. It's got to be moved from one place into another, and that prevents you from making dumb mistakes, deleting things twice. Also, because we have this with unique pointer, we don't have to implement a destructor. We can do rule of 0 on this mother because it will be destroyed. The destructor of Pube Grabber is going to call the destructor of unique pointer, which is going to call delete on whatever is owned. And there you go, that works. If we run this, we get the expected result. And what if we call pg.take, and we just drop that return value on the floor? It calls the destructor. Why? Well, because now the thing that we dropped on the floor is a unique pointer. So when the destructor of unique pointer is called, it is going to delete that memory. So you can't, if you use unique pointer correctly, you're not going to get memory leaks. You're not going to get double deletes. It makes your life easier, and you write less code. You don't have to write the destructor. You don't have to write the delete statement every time. Less code, safer, and fast as balls. You can't get any better than that. Now, there's a very common pattern in object-oriented programming called the factory pattern, and what that does is basically a function that will create some dynamic object and then return that. So it will return it, and then the ownership will be transferred to whoever called the function. Now, we can do that very nicely with unique pointers like this. We just return a unique pointer by value. And in here, notice that you don't have to do a std move because this local variable is going to be dying anyways. The compiler realizes that, and then it'll turn this into a move. And in fact, if you watched my previous video, you know that in optimized modes, it'll actually take the move out altogether. So we could do this. We could actually just do return make unique like this. That would also be fine. And what we could do, that's returning a temporary. We could do give make pube, and this should also work just fine because it is already an R value. You don't have to call std move on it. And there you go. So when you're returning a local or when you're returning a temporary, you don't have to do std move, but when you're returning something like this, a member variable, you've got to do that std move to say that it's okay to pilfer this thing. Now let me show you one last cool thing in this little code here. Remember that when we do the copy, the default generated copy constructor does a shallow copy, right? And that's bad when you're owning things by pointers, because now you got two objects pointed to the same thing. When they both try to destroy it, you get a bad time. Well, guess what happens when you have a unique pointer and you try to do a copy? The compiler says, nah, that's no good. You can't do a copy, it's deleted. Because you can't copy a unique pointer, so you can't generate the default copy constructor or the default copy assignment. So this will block you. If you have a unique pointer in your class, it's going to block you from doing something stupid like a shallow copy. Very nice. Notice that the default move constructor still works. I can do a move from one Pube Grabber into another, and the default is going to work, and it's going to work like you would want it to work. It's going to move the pube from one to the other. So good. All right, now let's take all of this smart pointer sexiness and stuff it up Meme Fighter's butt. So what we're going to do here is, first of all, obviously, you need to include memory, because we want to use unique pointer. Now, we want to migrate over these vectors to be vectors of unique pointer to Meme Fighter. Now, there is one annoying thing here, and that is you cannot initialize a vector of unique pointers using the initializer list like this, using the curly braces. It just won't work. You got to do pushback or something else. So we're going to do that. And that's going to look something like this. We just do std make unique. We push that back into the vector. Note that we're creating a vector of unique pointer to meme fighter, but when we do make unique, we are creating the concrete meme fighter types like meme frog or meme stoner. And we do the same for team 2. Now, there's two things we've got to fix up here. The first one, a little bit complicated, but we got std any of, right? It's going to iterate over all of our unique pointers, and it is going to call this predicate for each one. Now, we have a vector of unique pointers. We're going to try to pass them to a function that takes a naked pointer. You can't convert that implicitly, so it's not going to work. So what we need to do here is, instead of receiving each of these elements as naked pointers, we're going to receive them as references to unique pointers. So we can make them const references, and that will make this algorithm work. I'll talk a little bit more about this later, but you don't usually do this. It's a little special case there. The other thing we've got to do is, of course, happy times, we can delete this stuff because we no longer need to worry about freeing our memory. That happens automatically for us. And if I build this and run it, it should work. And indeed, it is working as designed. So there you go. Not too painful. Now, the other thing that we want to migrate over is, of course, the weapon pointer, right? Because right now we're owning it with a dumb pointer. That's bad. It's bad for a number of reasons. I've already demonstrated that. I'm not going to repeat myself. So how do we do that? Well, we take this dumb pointer here and we turn it into a genius pointer like that. And we don't need to initialize the null pointer. Beautiful. And then we just got to fix up a couple functions here. So pilfer weapon, let me just do a quick copy here. Pilfer weapon is going to be returning a smart pointer by value, a unique pointer. And in order to do that, it's going to have to move this. So std move from PWeapon, because that is a member. Wait, PWep? No, PWeapon. That's bad. That was the local. There you go. This should be fine. There you go. All right. So return that guy, move it out, give weapon like this, take it by value. You take your smart pointer by value when you want to transfer ownership. And then here we get rid of that delete, and we can just do the std move. Another beautiful side effect of using smart pointers, we don't have to worry about freeing the old thing before we move a new thing in, because when you do this std move, it is, if this PWeapon owns something, it is going to free that before it takes ownership of the new thing. All happens automatically. Of course, destructor, not necessary anymore. All happens automatically. If we build and run this stuff, it's just gonna work. It's just gonna work, because smart pointers are the sexiness. And now we don't have the problem of if we call pilfer weapon and we drop that return value on the floor, it's not going to leak memory because it's a unique pointer, and when it dies, it's going to free its weapon. The main thing I want you to know, and the thing that beginners mess up the most when they start using smart pointers, is that just because you're using smart pointers doesn't mean everything you pass in has to be passed in with a smart pointer. That is a mistake. All these functions, leave them the same. The only time really you should be passing by smart pointer is if you are transferring ownership. Otherwise, just pass in with a normal reference or a normal pointer sometimes. Don't pass in with a smart pointer. Actually, that reminds me, this here, we should be passing this in by smart pointer as well, because we're transferring ownership during construction of the meme fighter. So this should also have been a smart pointer. Let me just fix that quick. So meme fighter is going to accept the weapon by a unique pointer here, and we're also going to have to accept the weapon by a unique pointer in the children like this. And finally, we're going to have to make unique for all these weapons here. And there you go. We have purged the final news from our program. It is now modern C++, sexy as fuck. All right, let's have one more example of rejiggering a class to use smart pointers. So we got our surface. It is owning its pixels with this dumb pointer. Let's use smart pointers. So in surface.h, we include memory. We change this to a unique pointer, an array of color. In surface.cpp here, we're going to use make unique color array, and the number of elements is width times height. Down here, what do we got? Okay, so p-pixels, we're stealing the pixels from the donor. So what we do a std move here, and now we don't have to set this to null pointer. This destructor, we don't need it at all now because destruction is handled automatically, so we can get rid of that. And I guess that means that I should have deleted this one as well. Actually, I lied. We don't actually have to do anything here, because what's going to happen is the default move constructor is going to do what we need it to do. So we can delete this altogether. We don't have to define our own move constructor. We do have to do the copy constructor, because the deep copy default will not do that for us. And that's simple here. We're going to replace this code with this code here, because what this is going to do is it's first going to delete whatever is owned, and then it is going to put this new one in there. So that's much simpler. Again, this move, we're not going to need it. I'll show you that in a second. And that's it. That is it all implemented. Now let me comment this out, and I'm going to comment this out. And I'm going to do something simple here. So I'm creating a surface S1, and then I'm going to create a surface S2 that is going to be move constructed from S1. Now if I do this, and if I run it, you're going to see something a little weird. So we create S1, let's step over that. Now let's step into this move construction here. Step into. You see, we're going into the copy constructor, but we should be doing a move construction. So you might be wondering what the hell is going on. Well, this is something that you need to be aware of. And that is the fact that if you supply your own copy members, copy assignment, and copy constructor, the compiler will not by default generate a move member for you. So what you need to do is, if you want to use the default move member, you got to put equals default here, and that will tell the compiler to actually go ahead and generate that move member for you. You want the default one. Now we step in, we step over, we step in, and it's done, because there's no code to step to, because it's the compiler generated one. But you can tell we did not step to the copy constructor, it did a move. And there you go, much simpler code, much safer code. No need to create the move members, you can just use the defaults. No need to create the destructor. Just the default generated one works fine for us. By the way, this isn't the final form of the surface class. I've got one more improvement to make that'll make it even simpler and sexier. But I'm going to put that in a separate bonus video. You can get the link to that on the wiki page for this video. Alright, so the last thing I want to do here is just go into the documentation for unique pointer and just go over a few of the things I haven't covered yet. So we've got some functions here: release, reset, and swap. Release is useful sometimes. It returns a pointer, returns the pointer. In that sense, it's the same as get, but it's different in that it also releases the ownership. So now the unique pointer will no longer own that pointer, and it will no longer be responsible for deleting it. So it's very good if you want to transfer ownership of the pointer to something that owns with a dumb pointer. You want to release it from the smart pointer. Reset replaces the managed object, so you can give it a pointer and it will delete whatever it's owning, and then it will start owning the pointer that you passed in. If you call reset with 0 parameters, that'll just cause it to delete whatever it is owning, and it'll empty the unique pointer. Swap will swap the contents of 2 unique pointers. Pretty simple. Get, simple. Get deleted. We'll talk about this in a second. Operator bool. So unique pointer can convert implicitly to bool, and that's good if you want to do an if statement and check to see if the pointer is actually owning something. Then we got the dereferencing and the arrow pointer. We've already covered these guys. I've also already covered the indexing operator. Here, non-member functions make unique. Now you can compare smart pointers, unique pointers to each other, and you can also compare unique pointers with null pointer, and that's about it. Now this get deleter thing, this is a little tricky. It's an advanced topic, but by default what the unique pointer does is it calls delete on the pointer that it owns. Now what you can do is you can specify different behavior for what it should do when it has to free the pointer. So you can give it a functor or a pointer to a function, and it will call that. So in the constructor, let's take a look at the constructor here. So there are versions of the constructor that take 2 parameters. One is the pointer, and the second one is the deleter, and that is the thing, that is the functor that is going to be used to free the memory. Now, this is useful because sometimes you want to own things that are not just things created with new. I'm going to give you one example. So in the MP3 loading code in the framework, there's a function we called create waveformat EX from MF media type. And what it returns is it will actually return to you a pointer to a dynamically allocated structure. So this is a kind of factory function. But we have to free that memory when we're done with it. But you can't free it with delete because it wasn't created with new. It was created with a different function called, it's some kind of COM memory allocation function from the Windows API. So to free it, you have to call the function co-taskmemFree. And what I did is, in order to use it, a unique pointer with this kind of memory, I had to supply my own deleter, which was just the co-taskmemFree function. So what I did, this is how you do it. You pass it in like this, and this is what gets called when that memory is freed. Again, like I said, it's an advanced topic. I just wanted to mention it here to let you know that it exists, but really you shouldn't worry about it at this point. Just remember it, and when you are older, it will come in handy. All right, let's review what we have learned today. First of all, use unique pointer whenever and wherever you can. Use it, use it, use it. With unique pointer, you can pretty much eliminate new and delete from all of your code now, and that is what you should be striving for. It allows you to write less code, the code you write is safer, and it's sexier, and just motherfucking do it. There's no reason not to. And when you do use unique pointers, don't then start to pass everything around by unique pointer. That doesn't make any sense. You should really only be passing by unique pointer when you are transferring ownership. And when you do so, pass by value, don't pass unique pointer by reference. Now, one exception to that is, like I've shown you, for algorithms for the functors, the predicates, you pretty much need to take a smart pointer in that case. But in general, pass by normal reference unless you are transferring ownership, and in that case, pass by unique pointer value. Now, one last thing I want to mention is that there's another smart pointer that you may have seen already called the shared pointer. Now, the problem with the shared pointer is it's often overused by people who really don't understand the differences between unique pointer and shared pointer and when they should be used. People who don't understand RAII. Shared pointer has its place, but actually it's usually you don't need shared pointer. So always prefer unique pointer if it fits. I'm going to cover shared pointer at some time in the future and its sidekick weak pointer, but for right now I want you to focus on unique pointer and learn how to use that because it is by far the most important one. That's going to do it for today. Thanks for watching. I hope you enjoyed the video. If you did, please click the like button. It helps a lot. And I will see you soon with some more C++.